These are some notes to help get you ready for our exam coming up next Monday. Today is Thursday, February 4th, and just a few things that we've done in class for those of you who have been gone so that you can get a little caught up. First thing, let's start with the worksheet that everyone's working on in class right now. This is the one that's called More Practice. Says ratio, proportion, and similar polygons. If you weren't here, or if you were and didn't write down the two examples that we worked off of it, first one we did was number 2. The worksheet is posted, so I'm not going to write out the problem. You probably already have a paper copy if you've been in class lately. It's the one that said the batting average of a baseball player is the ratio of hits to times at bat. So there's my game plan. I just need to know what I'm comparing, and then in the fraction, which one of the two I'm going to put on the top of that ratio. Then it says that Sammy Sosa had 643 official at-bats. Since that is a at-bat number, when I write a ratio, I'm going to put it in the denominator. It also says that he has a batting average of .308. A little different way of giving us our similarity ratio. That batting average of .308, if you remember your decimals, is 308 thousandths, which means that Sammy Sosa hits the ball 308 times out of every 1,000 times he is at bat. So there's our similarity ratio. Question is, how many hits did he get? Well, we have everything in our proportion written except for our variable for the number of hits. So we have written a proportion, two ratios set equal to each other, and now we're going to cross multiply. Remember, on every one of these problems, we are studying ratio and proportion, so that is the means that we solve these, even though in 6th grade and 7th grade, you may have solved similar problems in a little different way. This is the way we're working them right now. I'm not going to show all the steps, truly because I don't have a calculator right now. So I'm going to help you down a little bit, your way down through the problem. So cross multiply 1,000 times x, and that would equal the product of 308 times 643, and then finish solving that by dividing both sides by 1,000. Since we're looking for the number of hits, you will get a decimal for an answer, 198.044, but we need to make sure that our answer matches the question. You can't have part of a hit. So in this one, it does make sense to round to the nearest whole number. So he has 198 hints. On the exam, what I'm going to look for is, can you set up the proportion? Did you cross multiply to solve? Did you make your answer appropriate, which means if it only makes sense in the nearest whole number that you round it, and did you label? Those are the things that we will be grading. Okay, the next one we worked in class was a different type of problem. The one we just worked, we gave you a ratio, 308 to 1,000. Then we gave you one of the numbers, 643, and you were asked to find the other one. This second kind of problem, from the worksheet, it's number 5, is we're going to give you a ratio, but then we're going to give you a total. And because we don't give you one of the two missing pieces, missing parts of the ratio, then we can't solve this with a proportion. You'll see what I mean in a minute. It says a cable that is 42 feet long is divided into lengths in the ratio of 3 to 4. Or in terms of a fraction, 3 over 4. That's our similarity ratio. Tells us how the two things are related, and that is the short piece compared to the long piece. That's how they're comparing them. It says, what are the two lengths? Okay, we can't solve this one with a proportion because in a proportion, you need to be able to have a fraction equals another fraction, and you have to know one of these two numbers. We don't know one of those two numbers. What we know is the total of those two numbers added together. So we need a different method, and instead of a proportion to solve, we're going to solve this one with an equation, just a regular linear equation. Since the similarity ratio is 3 to 4, we know that the original numbers, since they add up to be a total of 42 feet, those two original numbers must be numbers that have been reduced down to 3 to 4. So that means there is some number that we divided out of the numerator and divided out of the denominator of the original ratio to be able to reduce it down to 3/4. So our goal is to find out what that number was that was reduced out of the original fraction. So define your variables. Short piece is 3 times whatever that number was. The long piece is 4 times whatever that number was, and together, meaning add them, they reached a length of 42. So this time we're writing a linear equation. Once you have the equation written, then I'm pretty sure everybody knows how to solve these from here. Divide both sides by 7, x equals 6. So the short piece is 3 times 6, or 18 feet, and the long piece is 4 times 6, or 24 feet. And if you add 18 and 24, you do get 42, so we know we have the right answer. This second type of problem, you are given a ratio and also given a total. Because of that, we have to define each of the two pieces in terms of a variable, write an equation, solve that equation for x, and then we can substitute back in to how we defined our variables to get our answers. Two different types of problems. For the sake of making sure you understand the difference, in class I worked another pair. So let me put these, or give these to you. Another pair. And this time let's just be even more specific. Whoops, hold on a minute. There we go. So this is type 1 of our ratio problem. First type. The first type will be the kind that we solve with a proportion. Our example says the ratio of dogs to cats at some kind of an animal shelter is 2 to 5. There are 12 dogs at the shelter. Whoops, there are 12 dogs. How many cats are there? Or at the shelter? Okay, again, identify what kind we have going on here. We give you a ratio of 2 to 5 of dogs to cats. So there's my game plan. There's how the ratios are all going to be written. 2 dogs for every 5 cats. Then we give you the value of one of those pieces. There are 12 dogs. Since all my fractions are written with dogs in the numerator, the dogs go in the numerator. And the question is, how many cats? We're asked to find one of those pieces. Ratio given, one of the quantities given, and you're asked to find the other quantity. Whenever you have a situation like that, you're going to set up a proportion, then cross multiply, divide by 2, and solve. There are 30 cats. Do make sure that you label your answer. Okay. Again, ratio is given. One of the quantities is given for a new situation, and you're asked to find the matching piece of other information. Type 2 of the ratio problems. Type 2 ratio problem. This one you're going to solve with a linear equation. Proportion will not work. And the big difference here is you will be given a total. Rather than one of the pieces. So here's our example. Again, the ratio of dogs to cats at this same animal shelter, dogs to cats, is still 2 to 5. This time, instead of telling us how many dogs or how many cats there are, we have a total of 56 animals at the shelter. How many dogs? How many cats? And we could ask you for one, we could ask you for both. Whoops, that's an M. Notice the difference in the questions. We still give you a ratio, but this time we give you a total, not just one. So when we write that ratio of dogs to cats, the 2 to 5, we don't know either one of these other two. That's why a proportion will not work. So here's our other option. There are 2 dogs for every cat, but 2 plus 5 doesn't equal 56. So there's some bigger number, and we've reduced it to get the 2 to 5. So 2x, 2 times some number, is the number of dogs. And 5 times that same number that's been reduced out is the number of cats. And together, that 2x and 5x, those original numbers of dogs and cats, add up to 56. So we still use the ratio, but we use them to define our variables, our 2x and our 5x. We write the equation and then we solve. 7x is 56, so x is 8. The number of dogs is 2 times 8 or 16. And the number of cats is 5 times 8 or 40. And if you double check those, add the 16 and the 40 together, you do get 56. So we know we have the right answer. Tomorrow in class, we'll take some more questions from the worksheet. We can work a few others. If there's anything that a lot of students ask about from the worksheet, I'll go ahead and make another video and post that. You will find a separate sheet and video identifying test information.